Welcome to the Explainer. Today, we're going to break down one of Python's most essential building blocks, functions. And hey, if you've ever found yourself copying and pasting the same lines of code over and over again, you're going to want to stick around for this.
Does this look familiar? You write a few lines to calculate, say, the area of a rectangle, and it works. But then, a minute later, you need to do the exact same calculation for a different rectangle. The temptation is to just copy, paste, and change the numbers. It's a really common habit when you're just starting out, but it makes your code messy and, honestly, a pain to maintain.
Yeah, it's a super common problem. This kind of repetition makes your code longer, it makes it harder to read, and it's an absolute nightmare if you ever need to update that logic. But what if I told you there's a much, much better way? A way to write that logic just once and then reuse it whenever you want.
Well, that's exactly what a function is. You can think of it like a custom tool that you build yourself. You define a block of code, you give it a name, and then you can call on that tool anytime you need it, anywhere in your program to get that specific job done.
Okay, let's really dive into this recipe analogy, because it's pretty perfect. A function is like a recipe, right? It's got a name, it's got ingredients, and a set of instructions. You write it down once. Then anytime you want to make that dish, you just grab the recipe. You don't have to figure it all out from scratch every single time. A function is your code's reusable recipe.
So how do we actually build and use one of these recipes in our code? Well, it's a really straightforward two-part process. First, you create the blueprint, and then you call it into action.
Step 1 is defining the function. That's the blueprint. It's you writing down the recipe and all its steps. And step 2 is calling the function. That's the action. It's you actually using that recipe to cook. And the best part is, you can call it as many times as you want.
And here's what that actually looks like in Python. To define it, we use the keyword def, followed by the function's name, in this case, greet user, and, really important, those parentheses. Everything indented underneath is the body of the function. Then, to call it to make it run, you just type its name, again, followed by parentheses. That's it. Blueprint and action.
Okay, this is great, but our greet user function is kind of rigid, isn't it? It does the exact same thing every single time. What if we wanted to greet different users? What if our recipe could handle different ingredients each time we used it?
This is where things get really cool. We can make our functions super flexible and powerful by giving them inputs. In programming, we call these arguments, and they're basically the ingredients for our recipe.
All right, so there are a couple of ways to hand over these ingredients. On the left, we've got positional arguments. Notice how we called the function with 27 first and Suraj second? Well, Python just matches them up by position, so it thinks the name is 27. Not what we wanted at all. But look at the right side. Here, we're using keyword arguments. We explicitly say age equals 27 and name equals Suraj. Now the order doesn't matter one bit, and our code is so much clearer and way less prone to bugs.
And check this out, you can even set default values. In this example, see how the y parameter is defined as y equals 50? That's its fallback value. So when we call the function with just one number, myFun10, that 10 gets assigned to x. Then Python sees we didn't give it a value for y, so it just says, no problem, I'll use the default of 50. This makes some of your arguments optional, which is another layer of awesome flexibility.
So here's the bottom line. Arguments are what turn your simple functions into these incredibly versatile, powerful tools that can adapt to different situations. Getting comfortable with them is absolutely fundamental to writing clean, effective Python code.
All right, now for a concept that trips up a lot of new Python developers. Seriously, this is a common gotcha, and it's all about how functions handle different kinds of data you pass into them. Pay close attention to this one.
Okay, first up, let's look at what we call immutable objects. Think of things that can't be changed, like numbers or strings. So here, we have a variable a set to 10. We pass it into our function. Inside the function, that value gets reassigned to 20. But here's the key. When the function is over and we print our original variable a, it's still 10. The function didn't touch it. The original is totally safe.
But watch what happens with a mutable object, like a list. We create our list, lst. We pass it into our function. Inside, the function changes the very first element to 20. Now, when we check our original LST variable outside the function again, bam, the original list has been changed. This is a huge deal and can cause some really sneaky bugs if you're not careful.
So, what on earth is going on here? Why the different behavior? It's because of something called pass-by-object reference.
See, when you pass a variable to a function, you're not giving it a copy of the object, you're giving it a reference. It's like giving it the address to where that object lives in memory. For a mutable object like a list, both variables end up pointing to the exact same list. So any changes made inside the function affect the one and only original. Python does this for efficiency, so it doesn't have to copy a potentially massive list every time you use it.
All right, let's do a quick recap of the key takeaways. First, functions are your best friend for keeping your code dry. That's don't repeat yourself. Second, the syntax is simple. Def to define the blueprint, parentheses open to call it into action. Third, arguments are the ingredients that make your functions truly flexible and powerful. And finally, always remember that mutable twist. Be super careful, because objects like lists can be changed inside your functions, while things like numbers can't.
So now you've got the blueprint for building these powerful, reusable tools. The real magic happens when you start applying it. So take a look at your own code. I guarantee there's a chunk of copy-pasted logic in there that's just waiting to be turned into a clean, elegant function. What's yours going to be?